POH, which is equal to, it is nothing but a negative logarithm of base 10 to the molar concentration of the hydroxyl ion. Larger the value of Kb, smaller will be the values of pKb and stronger will be the base and vice versa. I got the hydroxyl ion concentration as 0.002. So now I can shift this point and I can rewrite this as 2 into 10 to the power of minus 2. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called equilibrium. Under this unit, we have discussed about the ionization constant of an acids and bases, and also we have learned that how to derive an equation for dissociation constant of a weak acids as well as for the weak base. In addition to that, we have understood that what is a polybasic acids and polyacidic bases and the factors which are affecting to the acid strength we have understood, and also we have learned about what is a pH and POH of the solution. Today let us move on to understand two more important derivation, that is show that pH plus POH which is equal to 14. Meanwhile, we are going to understand one more derivation, that is pKa plus pKb which is equal to 14 which is equal to pKw. The ionization constant of weak electrolyte also we are going to understand, and what are the salts and how the hydrolysis of the salts will be taking place we are going to understand, and lastly we are going to solve the sum of the numericals based upon the pH as well as with the POH. So let us see how to derive, or let us understand how to derive an equation, that is pH plus POH which is equal to 14. So already we have understood that pH which is equal to a negative is a negative logarithm of base 10 to the constant molar concentration of the hydrogen ion. Similarly, we have understood that POH which is equal to, it is nothing but a negative logarithm of base 10 to the molar concentration of the hydroxyl ion. Correct, no? So this is one of the important equations and it will be carry for 2 marks. So what is a pH? So already we have understood that, which is nothing but a negative log of molar concentration of H plus ion to the base 10. Similarly, we have understood that POH which is nothing but a negative log of base 10 into molar concentration of the hydroxyl ion. Now, we know that molar concentration of the H plus ion into molar concentration of the OH minus ion which is equal to 10 to the power of minus 14. Now, what I'll do, I'll multiply this above equation with the negative log to the base 10. Okay. So, what will happen? Minus log of H plus ion into OH minus ion which is equal to minus log base 10 to the power of minus 14. So, we have an equation, that is log of A into B which is equal to log A plus log B. This is the equation we have. And one more equation we have, that is log A to the power of B which is equal to B into log A. This is the equation we know that from the log. Now I'll apply that equation to the above equation. I can rewrite that. Minus, I have taken it outside. So log base to the 10, log base to the 10 into molar concentration of the H plus ion plus minus negative log of base to the 10 into molar concentration of the H plus ion. Why this plus will come? Because the log of A into B which is equal to log A plus log B. And similarly, you can see that this will be looks like log of A to the power of B. So, I can rewrite this equation as minus of minus into 14 into log base 10 into 10. We know that log 10 values will be 1. Log 10 value will be 1. So, we know that the negative logarithm of base 10 to the molar concentration of the H plus ion, which is equal to pH, plus into minus, again it is minus the negative logarithm of OH minus ion, which is nothing but a POH, which is equal to 14, and the log 10 value will be 1. So this is the equation we got as we have studied from the definition. This is how we can prove that the pH plus pOH, which is equal to 14. Next, we will see the pKa of the solution and pKb of the solution. So what is the pKa? pKa is nothing but a negative logarithm to the base 10 of ionization constant of a weak acid, and it is equal to negative log base 10 to the power of Ka. Okay. Similarly, pKb of the solution can also be defined as negative logarithm of base 10 to the ionization constant of weak bases. So pKb is equal to negative log 10 to the B log 10 into Kb. What is Kb? Ionization constant of weak base. Okay. Now I'll take up an example. Let us take the pKb values for P and Q are 2.8 and 6.2. Which one will be stronger? So if you see that the values, okay, the Kb as well as with the pKb value, larger the values of Kb, smaller will be the values of pKb. Larger the value of Kb, smaller will be the values of pKb, and stronger will be the base and vice versa. If the Kb values are very less in the cells, obviously the pKb value will be more, so that base will become very stronger. If you see that pKb values are very less here, it indicates that the Kb values are very high, so that the P will be strong in nature. This is how the pKb of a solution and pKa of the solution and pKb of the solution can be defined. Next, we have one more derivation, and again it can be asked for 2 marks, and it is an important derivation. That is pKa plus pKb, which is equal to 14, which is equal to pKw. We know that at 298 Kelvin, the dissociation constant of a weak acid into dissociation constant of weak base, which is equal to ionic product of water. Correct? No? Now, for this equation, I will multiply with the negative log base 10 on both the sides. So, what will happen? The negative log of K into Kb, which is equal to negative log of Kw. We know that again log of A into B, which is equal to log A plus log B. And we also know that log of A to the power of B, which is equal to B log A. Now if you see that, I have written this above equation as negative log 10 Ka plus minus of negative log Kb, which is equal to the log 10 into Kb, and we know that log of Kw, which is equal to log of 10 to the power of minus 14. Now what will happen? So minus of minus 14 into log 10. So what will happen? We know that again log 10 will be equal to how much? It is equal to 1. So what will happen to the above equation? So the negative log of Ka is nothing but a pKa, and negative log of Kb, which is nothing but a pKb, and which is equal to pKw. Okay, so which is equal to how much? Which is equal to 14. This is how again we can derive an equation with the dissociation constant of a weak acid as well as with the dissociation constant of weak base, which is equal to the ionic product of water, and it is equal to 14. So hope you have understood with this derivation. Next we have ionization constant for weak electrolyte. Okay, I'll consider a weak electrolyte Ba here, and when I say that it is a weak electrolyte, we know that it undergo partial ionization. So Ba is undergo partial ionization to give Ba plus and A minus. So my weak electrolyte is Ba, which is undergo partial ionization to give Ba plus and A minus. Now, at the initial stage, I'll consider the concentration of my weak electrolyte as C at the initial stage. At the initial stage, we all know that only the reactants will be there at equilibrium and the products are not formed. Correct now? Now, when the reactants have started dissociating, so what will happen to the concentration? It will also get changes. So, I'll write this concentration, change in concentration as C minus C alpha. Then what is alpha here? It is nothing but a dissociation constant. So, here C is the initial concentration minus C alpha is a dissociated molecule. Okay. So, we know that this weak electrolyte which is dissociated to give B plus and A minus completely. So, that dissociation can be written as C alpha and C alpha. After obtaining this equation, now I'll apply the law of mass action to the above equation. So, what will happen? So, K is equal to molar concentration of the product divided by molar concentration of the reactant. We know that B is nothing but a C alpha and A is nothing but a C alpha divided by Ba is nothing but a C minus C alpha. And I can rewrite this equation as alpha into alpha, it is alpha square, C into C, it is C square. So, divided by C I have taken a common and it is comes outside and I can rewrite this as 1 minus alpha. So, here 1C and 1C get cancelled out and give rise to the K is equal to alpha square into C divided by 1 minus alpha. This is how the ionization constant for the weak electrolyte can be obtained with this equation. So, hope you all understood with this derivation again. Let us see with the completely with the weak acid as well as with the weak base. So, for the weak acid, Ka is equal to alpha square into C divided by 1 minus alpha. We know that the hydrogen ion concentration will be equal to C alpha, so that I can write that the molar concentration of the H plus ion which is equal to square root of Ka into C. Similarly, for the weak bases, we can write that Kb is equal to alpha square into C divided by 1 minus alpha, molar concentration of the hydroxyl ion which is equal to square root of Kb into C. Okay, this is how we can obtain a one more equation for the weak acid as well as for the weak base. Next, we have salts. Already in our daily life, we have seen the different kinds of salt as well as in your laboratory, you have seen the different kinds of salts. Correct now? Then what are the salts? The salts are obtained by the combinations of acids with the bases. When the acids and bases, when they combine together, results in the formation of salts and water. So, this you have already studied in your 10th standard. That is, acid plus base give rise to what? Salts plus water. Okay, and we call this reaction also as neutralization reaction. As salts are the substances which are formed by the combinations of acids and bases. And there are only 4 types of the salts will be there. One is the salts of strong acids with a strong base, and another one is the salts of strong acids with a weak base. One more salt is the salts of weak acid with a strong base and the salts of weak acids with a weak base. Let us take an example of NaCl. How does it form when the strong acids with a strong base? Okay, example is strong base example is NaOH and acid is HCl. What will happen? So, Na combines with the Cl to form NaCl plus remaining water molecules will be formed. So, here it is in strong base and it is in strong acid. They combine together and forms of salts and water. We have one more example, the salts of strong acids with a weak base. I will take the example of strong acid as HCl and weak base as ammonium hydroxide. So what will be the product? So the product will be ammonia combines with the Cl to form ammonium chloride plus water will be released out. This is a strong base with strong acids, and this is strong acids with weak base. Okay, you'll get the salts and water. I'll take one more example, that is salts of weak acids with a strong base. So I'll take the weak acids as acetic acid, that is CH3COOH, combines with a strong base, that is NaOH. So what will happen? The CH3COO combines with Na to form sodium acetate plus water molecule will be formed. So this is a weak base with strong acid, which forms what? Sodium acetate with water molecule, that is the salts and water. I'll go with the salts of weak acids with the weak base. Weak acid is again, I'll go with the acetic acid. With weak base is ammonium hydroxide, as I used. It is a weak acid and again this is a weak base. So both of them they combine to form CH3COONH4 plus water molecule. So it is ammonium acetate. So that is sodium acetate and this is a ammonium acetate plus water molecules will be formed. This is how the combinations of strong acids with a strong base with a weak base with a strong acids, and weak acids with a weak base can also be obtained, and there are only 4 combinations with the salts. Okay. Next we have the hydrolysis of the salts. The salts hydrolysis can be defined as the reaction in which the cations and anions or both of the salts are reacted with water to produce acids or basic solution. So what is a hydrolysis of salt? It is simply nothing but dissolving a salt in water. Or if you take a salt and if you dissolve it in water, or if you put the water for that, it will become acidic solution or with a basic solution. The salts of strong acids and weak base, weak acids with a strong base and weak acids with a weak base undergo salt hydrolysis because the solution is acidic or neither basic in nature. So we have the reaction for that. Let us consider Ma is my salt, which I am going to dissolve it in water to give M is a cation whereas A minus is a anion. Now what I will do, I will take the M plus ion and again I will dissolve it in water to give what? MOH plus H plus. Okay. Similarly, this is nothing but a Kb value, that is a dissociation constant of weak base. Now I will take the A minus ion and I will dissolve it in water to give Ha plus OH minus ion, and this is nothing but a Ka. So if you see this equation, you can clearly understand that this is known as, the first equation is a dissociation constant of weak base. Second example is a dissociation constant of weak acid, which is dissociated to give Ha and MOH respectively. And from this I can say that if the Kb value is equal to Ka value, then the solutions will be neutral. Correct, no? Then the solutions will be neutral. Suppose if the Ka value is greater than Kb value, then the solution is said to be acidic. Correct, no? Suppose if the Kb value is greater than Ka value, then the solution is said to be basic in nature. This is how I can understand salt hydrolysis. Just understand, you are taking a salt and you are going to dissolve it in water to give rise to the respective acids or bases, and it mainly depends upon the dissociation constant Ka and Kb value. The next we have the pH of the solution of such salt solution. I'm talking what? Salt solution or the salt hydrolysis. So what will be the pH value, which is equal to 7 plus half into pKa minus pKb. If pKa is greater than pKb, the pH will be greater than 7 and the solution will be basic. If the pKb is lesser than pKb, pH will be lesser than 7 so that it will be acidic in nature. So these are the point which is very important to note you all for your CET exam. Next we have some of the numerical. Let us see how to solve this. Calculate the pH of 0.001 molar HCl solution. So they have given the molar concentration of the HCl solution. We need to calculate the pH of the solution. We know that the pH of the solution is obtained by a formula negative log of base 10 into molar concentration of the H plus ion. So if you see this hydrochloric acid, we know that hydrochloric acid at equilibrium, it gives a H plus ion and a Cl minus ion. Correct now? And they have given the molar concentration of the hydrochloric acid, that is 0.001. And we know that this hydrochloric acid which undergo complete dissociation to give a H plus and a Cl minus ion, so that your concentration of the hydroxyl ion which is also equal to 0.01. Okay. So now I can rewrite this hydroxyl ion concentration as 0.001 also as 1 into 10 to the power of minus 3. Okay. Now I'll apply the values here. Minus log base to the 10 into hydroxyl ion concentration will be 10 to the power of minus 3. Correct now? So we know that log A to the power of B which is equal to B log A. Correct now? This is the equation as we have learned previous one. So it is minus of minus 3 into log 10. Okay, base 10. So minus into minus, it is nothing but a plus and it is equal to 3 and log 10 value will be 1. So the pH of the solution will be 3. What is the pH of the solution? It is equal to 3. And how to solve the equation or how to solve the problem if they have given the hydroxyl ion concentration? You need to go with the logarithm table. Suppose my log table value is 2.532. How to find out the log table for you? So here the after decimal what all the digits will be there, we call it as mantissa, and before that decimal whatever the digits will be there, we call it as a characters. Okay. So here since we have only one number, after that we have a decimal, so that the log value we have to see under 2532. How to see this? So here we have a log table. So under 25 we need to see the 3 and 2. So under 3 in the sense this is a 25, under 0, 1, 2 and finally 3. So this is a log value, that is 4031. And we also have one more number, that is 2. So how to find out the 2 here? The same when you comes out, under the mean differences, under 2 we need to see. So it is 3. So 4031 plus 3. So 4031 plus 3. Correct now? So you'll get 4034. This is a log value. Since as I said, we have the point in between the two numbers and we have to write this log value as 0.4034. This is a log value for this number. Suppose if the point has been kept between the two numbers, 25.32, the log value will be same, that is 4034. But after two numbers we have the point, so that I'll write 1.4034. Suppose if the numbers, there are three numbers, then they have kept a point, then we need to say the same log value with the next number 2. This is how we used to see the log table while solving the numerical. So hope you all understood with this small example as I explained. Okay, and remember with some of the common equation or the small common formula which we are using while solving the numerical. Next we have one more numerical, that is calculate the pH of 0.01 molar sulfuric acid by assuming complete ionization. Again we need to write the ionization of H2SO4, that is H2SO4 dissociated completely to give H plus 2H plus ion and SO4 2 minus ion. They have given the dissociation value of H2SO4, that is 0.01 molar, whereas for the H plus ion we need to calculate this, and we have how many H plus ion? 2H plus ion. So it is 0.001 into 2. So we will get the concentration of hydroxyl ion as 0.002. Okay. Now I will apply the pH formula, that is pH is equal to negative log of base 10 to the power of H plus ion. Now I got the hydroxyl ion concentration as 0.002. So now I can shift this point and I can rewrite this as 2 into 10 to the power of minus 2. Correct, no? 2 into 10 to the power of minus 2. Now I can rewrite this as log 10, log base 10 into hydroxyl ion concentration will be 2 into 10 to the power of minus 2. Correct, no? So it is minus of minus 2 into log 2. We need to see that because we know that log a to the power of b, which is equal to b log a. Now you need to see the log 2 value. Log 2 in the sense log 20 value we need to see. So this is a log 20 value. Under 0 is 3010. Since we have only one number, we need to start with 0.3010. So that I can write the values of log here. So 2 plus 0.3010. If you add these two, you will get, so this can be written as minus log a into b. So how we can write log of a into b, which is equal to log a plus log b. Correct, no? So we know that what is the log a? It is nothing but a 2 into log 2, okay, into log 10, okay. So minus 2 minus log minus of minus 2 into log 2. Correct, no? So I can rewrite this as minus of minus 2 into log 2. So what is the values of log 2 here? So it is nothing but a 3010 as we have understood, and it is equal to 2 minus 0.3010. So how much we get if you subtract the 2 with log of 20 is nothing but a 0.3010. So you will get 1.699. So please see that while solving this, just putting the hydroxyl ion concentration, if you are applying the log a to the power of b, it's not correct. You need to apply with the log a into b. So log a into b is nothing but a log a into log b, and again log a to the power of b is nothing but a b into log a. That is why I got this answer. So hope you all understood this. First do the log a into b, then go with the log a to the power of b. So hope you all understood with this numerical. So in the next class, we are going to understand what is a buffer solution. So hope you all understood with this session. I'll come back with the next remaining topics of this unit. Till that, take care and be safe. Thank you.